Hello, everybody. How are you? Welcome to our live solve tonight. And we're really pleased to be collaborating again with Math Kangaroo. First, I want to double check. Are you guys able to hear me? In fact, I need to explain how our system works if this is the first time you've ever come here. The way this works is that if you'd like to say something, in order to make sure that the room is not too chaotic, you send a message to Chat Relay. And the way you do that is inside your Zoom, you go and pick who you want to send to, you choose Chat Relay, and whatever you type there will appear here in about 10 seconds. Oh my gosh, Chat Relay has a sense of humor. Chat Relay already said send to me. I like this. But I just wanted to say this because for this particular audience that we're teaching, we know that many of you have not been in our room before, and so we want to make sure everyone has the way to use this. Oh, good. So it works. And I also see that Chat Relay, which by the way is a person, it's actually Mr. Relay. It looks like he is real. This is very good. Right, so now this all works, and I just wanted to let you know what you have come into. This is a live solve that we're collaborating with Math Kangaroo for. 1 second, please. I'd like to request that people who are in the main Zoom room, please mute. We actually have this time a co-host here who's capable of muting that person. So yes, please mute when you, yes, thank you. Okay, I see that there are people who are helping with this. Thank you very much. Right, so the way that this system works is that if you want to communicate, what you should do is you should send your messages to Chat Relay because we're actually not having people unmute and talk inside the session. This will help keep everything more focused. But now, again, this is something which is the Math Kangaroo grades 3 and 4 live solve. If you've been part of our live solves before, you'll notice that the 3 and 4 is a relatively low grade. That's because we try to be as inclusive as possible. And so this particular one is aimed for people who are a lot younger. If you happen to be at a grade which is much beyond grade 3 and 4, please be patient. Remember what it was like when you were in 3rd grade, and we're going to have some fun. Now, I should probably say a little bit about myself. I'm Po-Shen. Some of you know me from the YouTube channel that I run. I'm a mathematician. I'm a math professor at Carnegie Mellon University. And at the same time, I work a lot on online education, which is why I happen to be here tonight. But you're not here just to listen to me. Actually, we have some really incredible people here. And we are also thrilled to have a representative from Math Kangaroo. In fact, this is Maya. Maya is somebody who participated in a lot of these events before, and she'll actually take it from here and say a few words. Maya, why don't you go for it? You just have to unmute and you'll go onto the screen for everybody.
Hi, I'm Maya and I'm in 11th grade. I've been participating in Math Kangaroo for 7 years since 4th grade, and I really enjoyed doing it. I like competing in Math Kangaroo because the problems are very different from anything I get to do at school, but also different from problems I do in other math competitions. I think the Math Kangaroo problems really have a variety of different topics, which I really like, including logic problems, which are my personal favorite. And the problems are hard, but I think they're also interesting. And I've definitely gotten a lot better at math over the years through doing Math Kangaroo problems. And I've also had a lot of fun through Math Kangaroo. I like the problems themselves, but I've also got to meet a lot of friends through it and gotten to study with them and do fun things. And I've also gotten to help younger students practice for Math Kangaroo by helping out in Math Kangaroo classes. And I've also gotten a lot of different fun prizes and different colored t-shirts that Math Kangaroo gives to everyone that participates. So that's why I really like Math Kangaroo. And now I will introduce the co-hosts from Daily Challenge. So Aiden represented Texas at Math Counts Nationals and received an honorable mention on the USA JMO in 2022. He's also the captain of his science bowl team. In his spare time, Aiden hangs out with his band and basketball team. He enjoys listening to K-pop, especially IZ*ONE and Twice. And Megan enjoys participating in math competitions, both locally and nationally. She represented Nevada at Math Counts Nationals and is qualified for a math prize for girls. She's also president of her school's math club and active in her local math club, including being on the competition team and volunteering over 100 hours per year. She also plays violin and speaks Spanish. And Professor Po-Shen is a math professor at Carnegie Mellon University and the national coach of the USA International Math Olympiad team. His innovations have made headlines in national newspapers across a breadth of topics from pandemic control to education and talent development. He shares his experience with the public through YouTube videos, which have totaled over 15 million views, and through his online math school daily challenge with Po-Shen. Thank you so much.
Wow. Well, thank you for that very kind introduction. And actually, thanks for introducing my co-hosts tonight. In fact, they are much, much more interesting than I am, which is why I really enjoy doing this together with them. So again, if you just came to join us, the way you participate tonight in talking is that you just type messages to Chat Relay. And now that we are on, all of us actually have the Chat Relay system down here. Just to answer a very quick question, the answer is yes, I am real 3.1415. However, I'm actually going to drop off in a moment. Not in a moment, I'll be back. I'm here the entire time, by the way. But I'm going to let one of our high school co-hosts go first. And I just want to remind everyone, send your messages to Chat Relay. Feel free to talk as the whole thing is going on, because we like to see your ideas. In fact, our co-hosts might ask about your ideas too. And we will actually be doing this thing relatively slowly, because this is designed for a 3rd and 4th grade audience. If you're older, please be patient. With that, let's toss it to Aiden. Aiden's going to take the first question. Go for it.
All right. Hello, everyone. I'm Aiden. And oh, wow. OK. Someone had me for Module 1, but let's get started with the first question first. All right. So Buzz the bee wants to reach the flower. So we have a bee named Buzz and a flower. Which set of directions will get him there? And then see empty diagrams next slide. Okay, so we have 5 answer choices here, and they're filled with arrows. So basically, the bee can move to the right. The bee can also move down. If we look at our answer choices a little bit right here, we might notice that none of the answer choices have the bee moving up. We have all these down arrows right here, right? And a bunch of these right arrows. So in our situation, the bee can move right or also down. Okay, but which of the answer choices could it be? How could we start this question? What do y'all think? Oh my, okay, there are so many answers in the chat. Okay, people think it's A. Yeah, okay, let's see A. What I'm going to do is I'm just going to directly take the answer choice and test it to see if it works. And it probably will work, because a lot of people, oh my, okay, a lot of A's, A. Okay, let's do this. So the first one is going right. So the bee goes right. We go to, ooh, that's a bad color, yellow on yellow. I'll do purple. Purple's a complementary color. Okay, so it goes right, and then we go down. We go down, and then we go right again. So right here, and then we go down twice. So down, and then right again. V wants to reach the flower, and answer choice A, we do reach the flower actually. So I agree with all of y'all. Answer choice A is also what I would choose, and probably the correct answer. Let's see. Yay, okay, it's answer choice A. We did not need the empty diagrams.
Awesome. I must say, I do love how the yellow of the diagram matches your shirt, Aiden.
Oh
that
my
is
gosh.
an amazing coincidence.
Oh wow, this morning when I was picking my shirt, I was like, okay, I want to wear yellow to school today, but I don't want to wear yellow to lifestyle again because I wear yellow every time. But it's fine.
And it was picture day at my school, which meant I totally dressed up and did not just wear the same thing I wear every day, which is fun. But real quick, something cool about this question that Aiden just went over is if we don't want to draw a diagram, we can see that Buzz is going to have to move to the right 3 times, 1, 2, 3, and down 1, 2, 3. And so we can look for the option with 3 right arrows and 3 down arrows in any order, which is A. So yes, great job, you guys. And time for the next one with another amazing name. Rositza, I believe is how you pronounce that. Let's go with that. Rositza wants to put 2 coins in each row and in each column in the grid. What coin does she need to move to an empty cell? Okay. And it looks like people are saying A once again. Okay. So, okay. And we have some people saying C. So let's look at how many coins are in each row and in each column. So in the first column, we have 3 coins, 1 coin, 2 coins, 2 coins, 2 coins. And for the rows, we have 2 coins, 2 coins, 2 coins, 1 coin in this 4th row, 2 coins in the bottommost row. So the problematic column is the first column, and the problematic row is the 4th row. And and the 5th row, because the 5th row has 3 coins. Oh goodness, I did not read that correctly at all. Okay, the first and second column have 3 and 1. The 4th and 5th row have 1 and 5. So we need to move something from the first column and the 4th row. So that means we need to move C. My audio cut out for a bit. I do not know how much of that you guys heard, but basically we need to move something out of the first column and the 5th row because those both have too many. And so that means coin C. Just like you guys are saying. Awesome job.
Yay! Okay, good job, guys. Oh shoot, okay. I just knocked off my headphones. Okay, but about this question, actually, one way you could do is there are so many coins, and we want to move one specific coin. So, I mean, the answer choice is limited to 5. So the most we'd have to test is 5. But we'd also have to decide where do we want to move it. So this is kind of a difficult process. But I like how Megan just notices the first column has an extra one. The last row right here also has an extra one. So if they both have an extra one, and you're only able to move 1 coin, then it has to be that common coin. So that was a really smart idea, Megan. Awesome. Let's move on to the next problem. Professor Lowe?
Yes. Hello, are you guys able to hear me? Oops, just a second. I'm just double checking. Are you guys able to hear me? I might have an audio problem.
Yes, it looks like the chat says yes.
Oh, you are able to hear me. Oh, okay, just double checking because I didn't hear that our people said yes. But I just wanted to double check one more thing. I actually was just resetting my computer because I had something go down. Did we already finish the Kangaroo question?
We just finished the coins question.
The coin question. Okay, that was what I,
Yes.
okay, very good. So we're on the Kangaroo question. So I'm on the right question. Is that right? Okay.
Yeah,
Are we
that should
good?
be right.
Yes, thanks everyone. Okay, and thanks for putting up with me. Great. So I guess I'm doing this. It's a cute kangaroo. Kangaroo always makes always makes one large jump followed by 2 small jumps on the number line, as shown in the picture. Kangaroo starts at 0 and ends on 16. What is the number of jumps that Kangaroo makes? Interesting. Well, let me see what I can do here. So first of all, I'm adjusting this thing so that I can see myself a little bit more clearly. So from 0 to 16. And so if you have 1 large jump followed by 2 small jumps, there's a couple of different ways that we could try to do this. I think that one of the things that Math Kangaroo tried to do here is they tried to choose the numbers to be small enough so that you could actually list it all. And if you actually listed it all, you could possibly see that you start from 0, and after 1 jump, you're at 2. After 1 jump, you're at 2. After 2 jumps, you're at 3. After 3 jumps, you're at 4, and so on. And if you just keep going, you'd be able to find it. But I wonder if there's a more clever way. And if I look at this, what I'll say is, well, if I go from 0 to 16, can anyone tell me, just type into the chat, how many steps does it take to get to 16 if I do 1 step at a time? Pretend it was 1 step at a time. Good, I see all these answers coming in. It's 16 one-step steps to go from 0 to 16. And then I guess the next question is, well, sometimes I do a 2 jump. If I do a 2 jump, how much do I save? The way I'm thinking about this is for each 2 jump saves how much? What I'm saying here is that if I do a 2 jump, which is this big jump, I save myself 1 jump. Is that right? I save 1 jump. Saves 1 jump. Okay, so that means that the answer would normally have been 16. It would normally have been 16. But could I figure out how many 2 jumps I make? Because that will tell me how much I save. Does that make sense? So it's like, I'm going to be doing 16. No, just kidding. I save some. And how much do I save? I save the number of 2 jumps that I make. So now I'm curious. Question. How many 2 jumps? And I see lots of people are putting things into the chat, which is great. I want to say, whenever we teach, we actually always want to ask for reasons, not just numbers. So how would you know how many 2 jumps you take? Well, I guess I could see that we're always going to take 1 big jump and 2 small ones. So it looks like every time I move a total distance of 4, right? Every time I move a total distance of 4, I get 1 of these big jumps. I see that there's some disagreement right here of how many 2 jumps I'm actually making. You see, I see, oh, this is interesting. One person said 1 of every 3 hops is a 2 jump. That's true. But the way I want to think of this is how I'm moving across and making progress, right? And I see a bunch of people, somebody's saying 4 times 4 equals 16. What I'm saying is that every time I go a total distance of 4, there's a 2 jump, okay? Ah, I see it. Yo has a great comment. Every time you go 4, you have a 2 jump, okay? And that's the idea I want to use. Let me erase this thing and just say every 4 distance get a 2 jump. Okay. Now, can anyone tell me how many 4 distances do I travel if I'm going 16 total distance? What would I do? I'm doing 16 total distance. So I have the number 16, and I also have the number 4. 4 is every 4 distance, I do a 2 jump. So I do exactly, I see it, 16 divide 4. Well, that's equal to 4 is the number of 2 jumps. I'm just writing this very slowly because I want to make this as understandable as possible given the audience age level. All right, now if I take 4 2 jumps, how do I get the answer? Remember, each 2 jump saves a jump. I had, if you put your reasoning in, it's more likely for us to want to see it appear on the chat too. So what we have here is that normally you take 16 steps, but then I'm going to have 4 of them be 2 jumps. So what do I do with my numbers? I have 16 total steps, and how much do I save? I save 4, right? So it's the answer is 16 minus 4, I think. Hopefully this is right. I think the answer is 16 total steps that I would take, except that I save 4 because there are 4 2 jumps. And I think the answer is 12. Is that right? Yay, it's 12. Okay, and I like how people were participating in the chat too, because what we try to do is we try to make this something that everyone can contribute their ideas as we go. Did my co-hosts have anything to add?
I think that was a great way of solving this question, especially the second part you brought up, not just listing it out and counting, because maybe this question, this will be 16, but maybe next year, the question, it'll be 16,000. So you never know.
That's right. Great. Who's up next from our team?
All right, I'll go next. Okay, next question. So 2022 plus something is equal to 2020 plus another something. Which two numbers can be written in the two boxes to make the statement correct? And then, of course, 5 answer choices. We could have 3 and 5, 4 and 1, 3 and 4, 7 and 2, or 9 and 8. Okay, I see a lot of A's in the chat, but I don't believe y'all yet, because why is it A? That's the question here. Why is it A? So let's think about it. What does an equal sign sort of mean? This is important to the question, the equal sign. Okay, so when we have an equal sign, that means the two numbers on both sides are equal. So in this situation, we could think about it in this way. Suppose we had, I don't know, I'm going to make a word problem. Suppose we had a bunch of apples, right? And then we're counting the apples. It's the same pile of apples, so there will always be an equal number of apples. But one side, we have 2022 plus something, and the other side, we have 2020 plus something. The thing about these two numbers is that they're really big numbers, but they're also really close. So currently, this side has 2 more than this side. So if this one has 2 more, but they're equal, we're going to have to make up that difference using the 2 numbers in these boxes, right? So 18 and 20 factorial. Oh, wow. Okay, yeah. I do see that Andrew mentioned that 2022 minus 2020 is 2. That's exactly the key. This is because the numbers difference is by 2. Thank you so much for the reason. Oh my gosh, I believe y'all now. I believe the answer is A. Let's go through this together then. Okay, get rid of the apples for now. This side has 2 more. So in order to make up for that difference of 2 we have right now, this side should have 2 more in the box. So there's this number, and then there's 2 more than that number. Now, out of these answer choices, the only ones that are 2 apart are 3 and 5. But it's also good because 3 is 2 less than 5. So the right-hand side right here has 2 more than the left-hand side in this box. And if we test 2022 plus 3 equal to 2020 plus 5, they're all equal to 2025 is equal to 2025. So I believe y'all, and thanks for putting the answers. Wow, I see a lot of 2000s in the chat. That's a good sign, and a lot of good reasons. So I believe the answer is A now. Of course, you can also just look at the answer choices and be like, it's gotta be A, because it works. Awesome, let's check if that's actually the answer. And yes, that's the answer. Good job, everyone. All right, Megan, do you have anything about this question?
That would be bad. I was just going to say, I think that it is really cool that we were able to see so immediately that the 2 numbers in our answer choice are going to differ by 2. Because if we think about it, 2022 is 2020 and 2, and 2020 is 2020. So we have 2020 and 2, 2020 and nothing else. We add one thing to each side. 2 and what is what out of our options? 2 and 3 is 5. And if you think of numbers with multiple digits as addition, then that makes this a lot easier, which I think is really cool. But yes, it seems like you guys have concluded that it is A, which was definitely correct. So great job.
Oh, I just wanted to point out an interesting chat message real quick. I saw someone said y'all with a question mark in the chat earlier. And okay, we're gonna have a cultural exchange moment real quick. I'm from Texas, and that's very south. So okay, when I first did this, I didn't actually realize y'all wasn't commonly used in the US. So you'll hear me say y'all a lot today because I just searched it up. Y'all is used more in the South. So y'all means you all, or it also means you guys. So just as a clarifying thing right there.
Yeah, no, I use y'all I'm from Arizona, currently live in Nevada. Never set a foot in Texas. But I started using it so that I could have a good English translation for the Spanish word vosotros back when I was learning Spanish. And for some reason it stuck around. So now I am honorary Texan. But
Yes.
I am more than honorary mathematician, so let's take a look at this new problem. 5 cars numbered 1, 2, 3, 4, and 5 are moving in the same direction. First, the last car passes the 2 cars ahead of it, then the second to last car passes the 2 cars ahead of it, the middle car passes the 2 cars ahead of it. Those are colorful cars I see in chat. That is very correct. Okay. Oh shoot, looks like I might be a little bit too close so that you guys can't see this. Okay, that should be a little bit better. And I actually know. We are going to draw ourselves a nice little diagram. So that can go shrink because I am going to read it aloud as we walk through these steps. And the first step is to write our cars. 1, 2, 3, 4, 5. Then we look at the first sentence. The last car passes the 2 ahead of it. That means 5 moves here. So 1, 2, 5, 3, 3, 4. Then the second to last car passes the 2 ahead of it. So 3 over here. 1, 3, 2, 5, 4. Then the middle car passes the 2 ahead of it. So right here. 2, 1, 3, 5, 4. Oh shoot, that is a bit too low for your eyes, isn't it? There we go. Much better. Which option is 2, 1, 3, 5, 4? B, just like you guys have been saying. So yes, awesome job. And let's just go check that we are all correct. Yeah, okay, amazing work. Oh, shoot. Yes.
I realize this question is actually so much easier if you had 5 cars that actually exist are these colors. You could just move it in front and move it behind and all that stuff. That'd be a lot easier. But
totally, yeah.
in a test, of course, our way around that is to draw the picture possibly 3 times, or if you can do it in your head, do it in your head. But make sure that you're not careless.
If you have scratch paper, you can tear off 5 little bits and make the cars. And as long as you throw them away at the end, okay, if you do that, throw it away at the end or give it to your proctor. But it can give you a physical way of moving the cars around. Maybe not as colorful, but it certainly works.
That's a terrific tip. I love the idea of using your paper as not just a stuck piece of paper. Great. I think it's my turn next. So I'm just going to go jump ahead. What's next here? Oh, wow, more colorful stuff. I guess maybe it's just that Math Kangaroo grades 3 and 4 is also more colorful than the other Math Kangaroos. I haven't seen this much color before. Let's see. Oh, during my vacation, I sent the 5 postcards shown below to my friends. There are no ducks on Mike's card. Kara's card has the sun on it. There are exactly 2 living creatures on Paula's card. Lexi's card has a dog on it. There are kangaroos on Heather's card. Which card did Mike get? Oh man, I love these kinds of questions which are about logic. It's interesting. There's not a 2 plus 2. There's not a 17 times 36, but it's actually math. This is actually math when you have to go and think through logic. In fact, the math class I was just teaching today at Carnegie Mellon, I don't really think we had many numbers inside it. Almost the entire thing was just about logic. But let's see. So I need to now make some deductions. No ducks on Mike's card. Oh, I'm supposed to figure out which card was Mike's. I see some ducks. So now I know that D is not Mike. Okay, what else do I know? Kara's card has the sun on it. Well, that's easy. Oh no, that's not. There's 2 cards with the sun on it. I was going to say, there it is. I see Kara's card, but there's 2 of them. There are exactly 2 living creatures on Paula's card. Okay. Lexi's card has a dog on it. Oh, is there only 1 card with a dog on it? Can anyone else tell me? which card has a dog on it? I think there's only one of them. Which dog? Yeah, E. Very good. So now I got some information. I know for sure that this is Lexi's card. For sure. That settled it. So Lexi got this. Now, Lexi's card has a dog on it. 5 cards to my friends. Oh, I'm also curious. Are there only 5 names listed? Mike, Kara, Paula, Lexi, Heather. Okay, so that's 5 people. All right. So now Lexi's is taken care of. There are kangaroos on Heather's card. Oh, is there only one card with kangaroos? I think there's only one card with kangaroos. Which is that? I think that's B. B is kangaroo. I like it. All these people are participating in the chat. So Heather is this one. Okay. So now I've dealt with Lexi. I've dealt with Heather. What else do I have? Oh, there are exactly 2 living creatures on Paula's card. Given that I've already ruled out something for Lexi and something for Heather, I see lots of people typing C. That's right, C has to be Paula's card because Paula's card has only 2 living creatures on it. So now I'm ruling them out one by one, and now I know that Paula is here. All right, so in that case, oh wait, I have an arrow that says not Mike. So all these people are very excited now because if that's not Mike, well, then that has to be Mike. Mike, A. 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 Okay, it worked. Do my co-hosts have anything they want to add?
Wow, okay. This question gave me low-key nostalgia for 3rd and 4th grade. Because when I was in 3rd and 4th grade, we had these logic books. It was like, because in math, we were memorizing multiplication and division and multiplication facts. It's like, what's 3 times 3? What's 3 times 7? No one really liked math just because of that. So our teacher's solution to that problem was, we'll do 2 types of math. We'll do memorizing multiplication, because that's important, but we'll also do logic, because logic is a little more interesting. And I don't know if y'all have seen this before, but we would have like grids, like, okay, I'm gonna attempt a pretty bad drawing right now.
I know exactly what you mean. I'm gonna go find a diagram.
Yeah, these
one up
grids.
Aiden.
And it's like, Mike is a doctor, Mike is not a doctor, Mike does not do this, Mike and Jeff do not. It's a bunch of logic stuff, and you do checks and X's. So I think Professor Lowe's method for this question was definitely the quickest and fastest way to get your answer. But if you're stuck or you're just for fun, I find it very interesting also to attempt a sort of grid way to do this. So if you had Mike, Kara, Paula, Lexi, and Heather, and then in the columns, this might be a little bit hard, but in the columns, we'll do postcard A, postcard B, postcard C, postcard D, postcard E. And then basically what we would do in this chart is do checks and X's. And checks are if they get that postcard, and X are if they don't get that postcard. For example, there are kangaroos on Heather's card. So actually that's an automatic check. The logic behind this is that you either have 4 X's to get a check or just a check to get a check. So you would start checking and Xing and Xing. And then from the grid, you'll notice very interesting patterns. And ultimately, we'll get a check right here if we keep doing this.
Yeah, I actually loved those puzzles. They can get pretty complicated, but I found a few examples. So here's one that looks kind of like what Aiden has right here. And then here I found one that's being filled out that's a little bit more complicated. You can see they're actually sorting through, well, they're not doing a very good job of it. Wait, what is this one? Okay, normally what you'll see is something where they actually end up repeating. So you have, this is sorting through 4 categories: names, colors, signs, and money. And each of those is represented here. And actually, fun math terminology that you guys will get to see more about later, if you want to see how many ways you can pair 2 out of 4 things, there's actually a function for that. It's for choose 2. Very creative naming by the mathematicians, obviously. And that actually equals 6. So we have 6 of these little grids that show up, And we can see each pair of money, sign, color, and person to calculate it all. And it's all a very cool problem.
Awesome. And yeah, that's some foreshadowing for what you'll learn in a combinatorics sort of class. That's module 3, by the way. Okay, next question. Okay, slides. I will make this slightly bigger. Hopefully it does not cover my face. Okay, so Aladdin has a square carpet, Disney character. There's the same number of dots arranged in 2 lines along each of the 4 sides of the carpet. So it's a square carpet, and there's the same number of dots arranged in 2 lines along each of the 4 sides of the carpet. Unfortunately, one side of the carpet, gold, folded over. How many dots are there on Alan's carpet? Okay, so the first thing I want to focus on in this question is just the first 2 sentences. Aladdin has a square carpet. There is the same number of dots arranged in 2 lines along each of the 4 sides of the carpet. We have a hint of what that sort of carpet would look like in this. The thing is folded over, so we don't get the full picture, but we can attempt to draw the full picture. For each of these sides, we know what this right side looks like because it's not folded over, we can see it. I'll use a different color here. How does white sound? Let's do that. Or I'll use blue, actually. So we have one.
Blue is a great color.
Yes, the same color as this, except that might be a little dark. What if I use pink? Pink is always a good color.
You should use teal, and that is completely
Teal.
unbiased and not related to anything whatsoever.
All right, let's do that. So the first sentence tells us the sort of shape, but when we actually start trying to draw this, we realize this picture is critical as well, because we don't know how many are in this line. But of course, now we know, because there's 1, 2, 3, 4, 5, 6 on each side. So 1, 2, 3, 4, 5, 6. And then, well, there's another column arranged in 2 lines. So it's also like this. And now we start to have things covered. We're going to have to think, what will it look like over here, and then over here, and over here? But it's a square carpet, and they're all arranged in 2 lines. So it should be the same, right? It should be basically symmetrical. So then we can do this. 1, 3, 4, 5, 6. And same thing here. And then same thing for this. And then, of course, this is how the carpet should look, right? Okay, so many people say it's E, so many people say it's D. Oh, wow, okay. Okay. Now, why is it E and why is it D? I could count this, right? I could count this and I might get the answer correct. I might miscount and get the answer wrong, but counting is definitely a possible way to get the solution. However, I believe in better solutions, right? What's a more interesting solution? Let's see. There's a fight between D and E. Okay, none of y'all are giving me a reason. So why is it D or why is it E? I'll believe you once you give me a reason.
I think Michael gave you a reason, Michael Page.
Let's see. I will scroll down real quick.
They said,
Oh,
no,
wow,
there
okay.
are no dots in the middle, so it's E.
Oh, so we're trying to decide. Yeah. I see what y'all do. We're going to do a total minus parts sort of idea. We're going to calculate the total amount of dots as if everything was filled up evenly. So if everything was filled up something like this, we would know this would be 3 times 3. All right. However, this is not exactly filled up entirely, because if we focus on the middle, then there's a sort of gap here. If we look a little more deeper, there's actually 4 missing. We can see this by looking at the row. There's 4 in this row, 4 in this column, 4 in this column, 4 in this row. And so if we fill that up, this will be evenly spaced. So now, okay, let's do the calculation. Right here we have 6. Right here we have 6. And then 6 times 6, 36. But then we're counting the extra 4. So then 36 minus 4 is equal to 32. And yeah, this time E is the answer. E is my answer. Let's see if that's correct. Awesome. Anything to add?
I think that I've seen a couple of people suggesting that we could not only subtract the middle from the square, but we could also constructively count this. I saw one person suggesting that we count it like 6 times 2 down each side, and the same thing over here, and then 2 over the top and the bottom. We add that up, 12, 8, 12, and that gives us the same exact answer, which we of course love to see. There's totally a ton of ways to do all of these questions, but let's look at one way we can do this next one. So the students in a class sit in rows. There is the same number of students in each row. There are 2 rows of students in front of Robert and 1 row of students behind him. In his row, there are 3 on his left and 5 on his right. How many are in the class? So let's draw ourselves a little diagram. Here is Robert. Robert has 2 rows in front of him. Let's just draw 2 dots, and 1 row behind him. And Robert has 3 students on his left and 5 on his right. So, how many people is this? Well, we can see that this is 4 tall and 3 plus 1 plus 5, that's 9. 9 wide. And so if we take 4 times 9, we seem to be getting the answer that you guys are doing. So yeah, E seems to be correct yet again. So that is awesome. And let's just double check that. Amazing. Okay. Do you guys have anything else to add?
Not really. Generally, just when you have a row question, that's usually good news because there's going to be some sort of right track that you might be able to think of. So yeah, I think Megan explained this question really well.
Great. I think I'm up next. Is that right? I think I'm up next. So let's see. What's this? Wanda chose a few of the following shapes and said, among the shapes I chose, there are 2 colored shapes, 2 large shapes, and 2 round shapes. What is the smallest number of shapes that Wanda could have chosen? These questions are scary because it says what is the smallest number of shapes. Whenever I did these kinds of questions before, I would always be afraid that I found a number of shapes that she could have chosen, but what if she could have chosen a smaller number? And it was only a lot later when I started to learn about proofs that I could even figure out a way to explain, oh, I can be sure that it's the smallest. You know what I mean? Because like if you just did something and you said, here's a way of doing it, how would you know? So we actually have to do 2 things. We need to find a way to choose only a few shapes, and we need to know why you can't do better. All right, 2 colored shapes, 2 large shapes, 2 round shapes. The smallest would be called 2. If I can do this by picking 2, I'd be happy, but I can't. Because it has to be 2 colored and 2 large and 2 round. So I like colored, I like large, and I like round. I don't see any colorful round shapes. That's annoying. Oh, maybe I can use that as part of the way to solve this. So it's like, I need to pick something which is round. Here's how I'm going to think of it, okay? Oh boy, this is useful for both things. I was just going to say, is this a useful shape to pick? It's round, but it's not colored. Oh, but it is large. So I'm just trying to think of how it can be contributing to all of these different properties. Well, what if I start with the two? Oh, wait, I have to pick two round shapes. So I'm stuck. I must pick the two round shapes. You see how I'm thinking about this? I'm trying to say, is there anything that I can use to get a grip on this problem? And I just felt like I got a grip, because how can you pick two round shapes? Can anyone tell me what has to be true if you're picking two round shapes? Something has to be true if you pick two round shapes. Because if you look, where are the round shapes? There are only two round shapes anyway, the two circles. So no matter what, I know that I have to pick both of these. There's no choice. I have to pick both of these. That's the only way to do two round shapes. All right. Then the next thing I look at is I need to also, oh yeah, I finished the two round shapes already. So I'm going to mark it as done. The two round shapes, done. So now I also need to get two colored shapes and two large shapes. Can I get away with that with just one more pick? That would be awesome. Because I see that I'm not done yet, right? If I just pick these two, I don't have two colored shapes. I don't have two large shapes. Does anyone see what I could pick? I see it already. What could I pick that will give me two large shapes and also two colored shapes? There's exactly one thing to pick. I like it. Mike said big, the blue square. Pick the blue square. So let's also pick the blue square. That is the wrong pen for the check mark. If I also pick the blue square, then bam, I've got two large shapes and I also have two colored shapes. And that's how I know that the answer is 3 and not 2. Because I had no choice but to pick these two round shapes, stuck. And once I picked the two round shapes, then the question was, I'm not done yet, so I have to pick at least one more, and that one more did it. So I think the answer is B. Yes, it is. Okay. I love these logic puzzles. Aiden, I think you're next up, unless anyone has something they want to add about this.
I was just thinking, okay, this question, when you said get a grip on the question, that really I forgot the word, but I could really relate to that because sometimes for these
Resonated?
Resonated, yes. Okay,
Woo!
Do not forget language arts when you're doing math. But yeah, sometimes in a question, all you need is to grab some sort of thing, and then you'll feel confident, and then it'll be straightforward. But yeah, Megan, do you have anything for this question?
English be important, but math would be importanter, which is why I have a new math question for you.
Oh my gosh, okay. Yeah, I have a new math question for you. Here we go. A pyramid is built out of cubes. Each cube has a side length of 10 centimeters. Okay, that will be really important because look at the answer choices. They're all centimeters. So, you know, side length. An ant climbed up and over the pyramid as shown by the red line. Red line here, red line here. What is the length of the red path the ant walked? I feel like all Math Kangaroo questions are like this in a sort of way because there's a straightforward way to do this. What's the straightforward way to do this, guys? What is the straightforward way to do this? Should I say
Bring an
y'all?
ant and some cubes into your testing room and see.
Wow, okay, that's even more straightforward than I thought, actually. So, yeah, that's one way. Way one is bring an ant. But the way I was thinking of actually is we could count each length individually. For example, we could count this length. This up here, that would be 10. And then this right here, well, that would be 5 because that's half of the side length of the cube here. And then we have another 10, then another 5, and then another 10, and then a 10, a 5. We could keep going like that. We could do individual side lengths. Okay, I will write this down. Individuals. But this picture has to exist here for a reason, right? We got a really nice view from above, and it's a straight red line. That's good because that inspires us. What if we looked at things not as individual pieces, but as a whole? What if we looked at things as a whole? Wow, I see Victoria has a long chain of individual sidelines summed up. Yeah, what if we looked at the whole though? There are two types of lines in this picture. There are horizontal lines. I'll write that down. This will be important. Horizontal lines, and there will also be vertical lines. By horizontal lines, I mean the ones that are going flat. For example, this top one, or this tiny piece right here, also flat. Same with here. And then, of course, here and here. We also have up, and then up, and then up. The line's going up. I don't actually know how an ant can walk up. That kind of defies gravity. I think only geckos can do that. But mathematical ants are magic. So we'll just leave it there. So
Not
let's count
only
these two.
geckos. I think there's one
Not
that you
only
forgot.
geckos.
Minecraft
Yeah,
spiders.
maybe birds. Spiders, yeah. And magic ants.
Watch me
All
try
right.
to appeal to the youngins with my hip knowledge of Minecraft video games.
Oh my. Okay. So now let's look at these two parts, horizontal and vertical. Horizontal is nice, actually. The smart way to think about this is to look from the top. That's why this is here. This line covers all of these horizontal lines because just look from the top. You'll see this horizontal line, this horizontal line, this horizontal line. It'll just be a straight line looking straight from the top. So all that horizontal sum together is just this. And what is this? Let's look at the outer picture. This is 10, this is 10, this is 10. We could sort of move that red line down here to this yellow line. And that's 3 squares, 3 cubes. Sine length 10. Horizontal, we sum all those lengths up, we have 30 centimeters. It's really just this. And then vertical. Vertical, we look from two sides this time. So suppose we look at from this right side. Like if okay, how do I do this? If I look at it this way, then I'll see this going up. And then that'll be 110, another 10, another 10. It's just a straight line. They're 3 cubes high. So 3 times 10, that's 30. But then we also have to look from the other side. So if I go right here, and I look this way, then we see the same sort of line just going up. So that would be another 3 times 10. 3 cubes, each side length 10. So another plus 30. Sum all of these up. Then we get a total distance of 30 plus 30 plus 30, which is equal to 3 times 30, which is 90 centimeters. So yeah, answer choice E, that's what I got. And that also seems what y'all got. Let me see. 40 is the height times 2 for sides, 10 for the top. Yeah, for the 2 sides, 40, perfect. And 30 plus 2 times 30, exactly. E, yeah, the answer is E. No letter grade for y'all this time. The answer should be E, right? Okay, yay, the answer is E. Y'all got 90 on the quiz. Oh no, actually y'all got 100, that's good. Thanks for all the participation, and thanks for the explanation.
Yes. Oh, and for all of you visual learners, here's a little diagram of what it would look like from the side. We've got our view from above. Here's the view from the side. So, it's very nice. Yeah. Great answer, you guys. Okay. So now we've got Ahmad and Zaleh, who start moving from point A with the same speed in the directions shown, where Ahmad walks around the square-shaped garden and Zala walks around the rectangular-shaped one. They meet again at A, and they want to find the smallest number of laps around the square-shaped garden that Ahmad can take to meet Zala there. Okay, so let's figure out how far each of them are walking per lap. So, So A since they're walking around the square garden, that's 5 plus 5 plus 5 plus 5, or 5 times 4, because that is a formula we can use for the perimeter of a square. Okay, hopefully that's a bit bigger, but unfortunately, unless we want to have it block over my face, we can't make it too much bigger. I think we'll probably have to stick around that size. Hopefully that's a bit better. But yes, that is 5 times 4, which is 20 meters per lap. And as for Z, that is 10 plus 5 plus 10 plus 5, or 2 times 10 plus 5. 10 plus 5 is 15, double 15 is 30. Okay, so now they are going to walk in laps until they meet up again. And so since they're doing a whole number of laps, that they're going to be in multiples of these numbers. So what multiples of 20 do we have? So we could meet after Ahmed's watch. 20 meters, 40, 60, 80, and so on and so forth. And as for Zala, that is 30, 60, 90, 120. But wait, this 60 looks awfully similar to this 60, which is probably because they're the same number. So we can see that that is 3 times 20, or 2 times 30. So 3 laps for Ahmed, which is just what you guys are saying. Yes. And yeah, 60 is actually what's known as the least common multiple of these two, like Ian pointed out. So yeah, great job.
Cool. Oh, wow. This is colorful. Again, it seems like I keep getting all these colorful questions. And the theme of Math Kangaroo grades 3 and 4 is colors. The small caterpillar shown in the picture curls up to sleep. What might it look like? Oh, wow. And the head is a different shade of blue too. So you got to be very careful as you look. One thing I should say, by the way, is that we're actually getting towards the end of the time. So this will actually be the last problem that we do, unfortunately. But please feel free to communicate in the chat as we go. Let's see. Well, I've got a head. Can the head be in the middle? Actually, it can. Oh my gosh, this is complicated. I'm staring at this now. And I'm seeing there's some alternating blue. Oh, there's some alternating part and then a head. Is there anything that looks like a pattern where things are alternating? Oh, wow. I saw something. I think we can do B, but I'm going to tell you how I came around with this, okay? I wanted to know if there's something which might be an alternating pattern, and let me see if I can do B. I'm going to try to walk along from the tail onto the head. Okay, and I might be wrong. Let's see. So if I try to make it so it alternates pattern between colors, I can go from gray to blue to gray. Ah, it doesn't work. No, it doesn't work. Oh, it's because that piece is annoying. You see, I got excited because I saw all these blues here. So when I saw all these blues, I was thinking I could do some kind of a zigzag pattern, but it doesn't quite work because of that end. All right, maybe I should be thinking of it from the head first. Oh, yeah, let me try it from the head first. I'm going to trace them all from the head first, because then that gives me a forced direction, okay? Because then I can start somewhere. I'm trying to figure out how to systematically do this, okay? And watch, if I started from the head, I would have no choice. I would have to go that way. And then after I went that way, I have to go to a dark blue. But since it's curling up to sleep, I have to go down to this one, or else I won't ever be able to go to that one. And that's it. It's over. And if I'm looking at all of these different things, I wonder if I'm forced with a specific order that I have to go through. For example, if I start with the head over on this one, well, what could I do? I'm awfully attracted to try to go this way, going down. Because then I can go to the dark blue, then the light blue, the dark blue, a light blue. Oh my gosh, a dark blue, light blue. Actually, I think we can, in fact, do it. I think the answer is A. And I mean, I will go ahead and say I think the answer is A. But if I look at the other ones, I can probably explain to you why those don't work. Because, for example, if I'm this one, well, from the head, which way do I go? I've got two choices. If I went this way, then I'd be stuck because I need to go to a dark blue. And then what would I do after that? I have to go to a light gray and I'm stuck. If I didn't go to the left, I'm just explaining to you how I would think through this if I didn't have that idea right away. If I went to the right, now I need to go to a dark blue. I guess I could, but I see how I'm going to be dead. Because if I go across, at some point I need to come back around and I'll get two dark blues in a row. And I never have two dark blues in a row. So you see, I could have gotten A, but I want to show you how if you didn't see A right away, as you went through, you'd be able to eliminate the ones that don't work. And I know this one won't work because if I'm going back around, I get two dark blues in a row. Okay. So the next one is, what if I went to D? From D, I need to go to a gray. But I see that if the D goes to a gray, I'm also seeing on the D, at some point I'll have to cross from left to right or right to left. And that goes through two grays in a row, which you can't do. Right? You can't go through two grays in a row because if you start with this as the head, at some point you got to go through, it doesn't work. So two grays in a row, that doesn't work either. How about this one at the bottom? Well, at the bottom, if I need to go to a gray first, the way I see this is that somehow I need to cover the stuff on the left. Right, because if I went and did a gray first this way, for example, going to the right, my chat is covering it up. I'm going to temporarily move my chat to the other side. Oops, that wasn't the chat. That was the problem. Let me move the chat. Chat, up you go. Okay, there we go. So if I have this thing, you see, if I went across to the right first, then at some point, I'll need to go to a dark blue. If I went immediately to the dark blue, then I'm in trouble because that's already cutting me in half, so I can't go to the left or the right. So if I go to this dark blue, then I'll have to go to a gray, and then I'm stuck again because I have to hit the dark blue somehow, and I cut myself off. So I can't go that way. And instead, if I went either of the other ways, if I went up here, I've cut myself off because I'll never be able to go there. I need to go to a dark blue. And if I went here first, I'm just stuck because I need to go to a dark blue next. Okay, so I'm just showing you how there's no way to do it with any of the other ones. That's actually what a proof is. This is all about logic. And instead, we did find a way to do it with the A. So the answer is actually A. Let's see. It is A. Do my co-hosts have anything they want to add on this?
This caterpillar is crazy. Like, it can bend all sort of ways. At first, I was like, wow, this is alternating. So it has to be B, right? Because alternate, alternate, alternate. But then I realized there's all these different curves and possible methods. So really the only way is just go through and see, is this wrong or is this correct? And of course, if you have a physical caterpillar like this question might be a little bit easy. But for now, follow along with this, and then that's a very good method. Thanks for the solution, Professor.
Yes. I think there's actually a pretty cool way that we can rule out the other cases, but it would definitely be way more work than what the question calls for. And that's always something to keep in mind, because you can do something a really cool way, but your goal is actually to just do it the most consistent and quickest way. You can show off when you're skateboard, skate park, or whatever you guys are doing in your free time.
Cool. Yes, well, thank you. With that, that's all of the math problems we're going to do. Before I say a few wrap-up comments, I want to know, does the Math Kangaroo representative, Maya, would you like to add anything here? If you do, you can give me a thumbs up. If you don't, we're all good. But basically, you can tell me whether you want to add anything here. You won't be on camera, don't worry, until you decide, unless you decide to go. Otherwise, I'll just go and give the wrap-up. Okay, well, with that, I'll go ahead and give the wrap up. So first of all, I hope that you guys had some fun. I'm going to switch to the other way that I display right here. Right, I hope you guys had some fun. We actually definitely had fun. And I want to emphasize the reason why we're so happy to work with Math Kangaroo on this is because the questions are actually that creative. You see, before I even looked at the live solve for grades 3 and 4, I looked at my third grader and I was thinking, you know, what kind of math problems do you expect to ask to third graders? Okay, third graders are cute, and they work on thinking and talking and all of these things. But you know, sometimes you see people and they just do multiplication problems. And I've seen math contests before where the elementary school math contest is just a whole bunch of arithmetic. Okay, maybe. But then when we looked at these questions, what we found out is that we actually were thinking through all of it. And I also remember when I was in elementary school, I think Aiden made this comment about reminiscing about fourth grade when he was doing these kinds of logic puzzles. I was also doing these in elementary school. This is what we often did in these classes if you already knew how to multiply and the teacher was trying to figure out what to do with you. So I actually think that these problems are fantastic. For anyone who's watching and wondering, why are we suddenly doing third and fourth grade stuff on this channel that actually was doing AMC 10 live solves just recently? The reason is because everyone was third and fourth grade at some point. And so it's actually useful to go and think, what are good ways to go and build up skill? I do want to encourage everyone who's watching, if you happen to have third and fourth graders, do register for the Math Kangaroo competition. We certainly will with our third grader. And if you like what you just saw, stay tuned. We show up every 2 weeks to collaborate with Math Kangaroo. But for the next live solve, it's going to be quite a lot harder. It's going to jump to grades 9 and 10. So maybe you can you don't have to stay up quite as late if you're grades 3 and 4 to join next time. Regardless, we had lots of fun. Thank you to everyone who came tonight. Thank you to Math Kangaroo for working together with us, and see you next time. Bye-bye.
Bye, everyone.
Bye. Math Kangaroo is always so much fun. I love these live solves.